Hello everyone. So in this video lecture, we're going to look under the hood at the core components that make blockchain what it is. Just think of the blockchain like the car, right? From the outside, it could look all sleek, all fast, all reliable. But we know, right? It's the engine, it's the gears, it's the fuel system inside that is actually making it move. So in the same way, our blockchain is built on a set of foundation components, be it blocks, be it chain, be it nodes, be it consensus, be it cryptography, be it network, that are anyhow working together seamlessly to create trust in the environment. So in the next few slides, we're going to break down each of these components, what they are, how they work, and why they matter. So that by the end, you'll not just know what blockchain does, but how it does that inside out. So starting with the distributed ledger. So, we have the blockchain, but the heart of the blockchain is my distributed ledger. At its core, distributed ledger, you can say, is like the electronic database, right? But, it is unlike it in a way that instead of being controlled by one central authority, this ledger is shared, synchronized, and continuously updated across every participant that is there in the network. So how does it works? The transactions, we know every transaction, so every action in the blockchain is called a transaction, right? These transactions, they're actually grouped into blocks, and each block is linked to its previous one using a cryptographic fingerprint that we call a hash. And inside the block, every hash, they together make the Merkle root. So if someone even tries to alter a past block, the entire chain of blocks is going to be altered. And then we can know that this blockchain, okay, this chain has been tampered with. So that is how, in a way, blockchain is going to maintain its data integrity. Now, why does this matter to you and me? Because this is going to eliminate the need for a central authority, let's say bank, government, or anywhere, to validate transactions. So instead, the participants, that is the participating nodes in the transaction, the participating nodes in the network are going to reach consensus before anything is recorded, because they know once they have the transaction written up, it cannot be amended, right? The next block of the transaction can only be appended beneath its transaction. So every of the participating nodes in the network have to reach a consensus before they agree to write anything to the chain, right? So yeah, in simple words, if I tell you about the analogy that I've been using since decades, I've been making this video. Distributed ledger is just like a shared notebook. Everyone has the same updated copy in the network. No single person can cheat, and every entry is permanent, right? Because this is the foundation upon which everything else in the blockchain is going to be built upon. Let's come to the next. The next says consensus mechanisms. Blockchain makes a bold promise of being completely verified, highly secure. It's like I'm telling you that in this class, we will not have a monitor, but every student is going to, self-discipline himself. They're not going to talk when the teacher is not there. Seems a very bold promise, right? Because I know even if I don't do anything wrong, though I'll be the first person to do wrong, everybody else is going to do, right? So how do you think the thousands of computers that are spread across the world, across borders with no central authority, agree on which transactions are valid, which are not? So this is where the consensus algorithms play. This is where they come in. So what happens at the core, consensus algorithms are just simple CS processes designed to help the distributed systems reach agreement. So in the blockchain world, they ensure that every new block added to the network, everybody in the network first agrees that, okay, this is checked, this is verified, and now this can be appended to the chain. Once everybody agrees, just, imagine there's a group of people sitting in a room, so each has their own copy of a ledger. A new transaction comes in, and before anyone is going to write that in the chain, everyone has to be in agreement that, okay, this is verified, this is legitimate, and only then the transaction is going to make it into the block, and that block is going to be added to the chain. So that is consensus for you. That is consensus in action. So, there's not just one way to achieve consensus. We have a lot of different algorithms. Let's say proof of work, let's say proof of stake. Then another. We have many ones, but we're going to study in this lecture about the proof of work and the proof of stake. So each is going to come with their own trade-offs: speed, energy, activity, security. Yeah. So this is for you, the consensus algorithms. Please make sure that you're using the comment section. If anything is unclear, if you want me to just speed down, if you want me to just speed up, anything, please use the comment section. You can also use the Google Forms link that I've already added to the description for anything, any changes that you want me to make, right? So now let's start with proof of work. Proof of work was actually the first real world implementation of the blockchain consensus algorithm. Until date, it remains one of the most recognizable ones. Now, why? Because it powers Bitcoin. So how does it work? So, when a new block of transaction is ready to be added, this block of transaction will not be accepted by the network blindly. Instead, this will go on to all the computers who are competing on the network. We call miners. Here, everybody participating in the network, they're called miners. So what is going to happen? They have to, everybody will get a complex cryptographic puzzle to solve. And the first one, the winner of the cryptographic puzzle, whosoever solves it the first, has now the activity or gets the right to append the block, and everybody else has, and this appended block will get broadcasted to everybody else, right? So it's like I get the right. If I have won the cryptographic puzzle, I have been the first to solve the cryptographic puzzle, I get the right to add the block to the blockchain. And once it has happened, the solution or the proof is broadcasted to the rest of the network for verification. So, this ensures that adding a block requires real computational effort, which makes it extremely difficult for bad actors to manipulate the chain. You get it? Because you need a lot of computational power here, right? So, in some words, you may say that proof of work is going to trade energy and computational power for security and trust. I would like to repeat this line because this is something, I know proof of work with, or I remember how is proof of work and what is proof of work. So, it is just like proof of work consensus algorithm, it trades energy and computational power for security and trust. So whenever you hear about miners, you hear about mining, please know this is it. And there is nothing like this gold mine and everybody's mining it. No, it's about solving complex cryptographic puzzles to prove that the block is valid. And whosoever solves it first gets the right to append that to the blockchain, right? Let's go ahead with proof of stake. So, since proof of work is relying on a lot of computational power, and it has a disadvantage, obviously, because let's say there are 10 nodes participating, okay? And only one person can be the first person, only one person can be the winner, and that winner will get a chance to append that block to the chain. Now, what about the 9 people? They could be in some way, maybe in the middle of the puzzle, maybe half through the puzzle, maybe quarter through the puzzle. What about the computational energy they have used? It's all a waste, right? Because I am the winner. Now I don't care about the 9 people else participating in the chain. Their energies, whatever they've used for the cryptographic puzzle, are waste. So in this way, it's a lot energy hungry mining in this way. So then we have proof of stake, and proof of stake, it offers a far more energy efficient alternative. So how does it work? There, you remember, we used to call the participating people miners, but here in this case we call them validators. And instead of solving puzzles, what do the validators do? They're chosen to generate new blocks, again the same thing, but based on the stake. Now, how and what is the stake? The stake is the amount of the coins a validator holds. And sometimes, they also take into account how long have you held them. So the larger your stake, maybe the more coins I can stake, the higher are my chances to get selected. And if I am selected, I have the right to add the block to the blockchain. So, in other words, I can also say that those who are more invested in the system are given more responsibility to maintain it, right? So this is not only going to reduce the need for heavy computing power because I don't have any cryptographic puzzles, but in a way, just think of it. It is also rewarding the long-term coin holders. It is rewarding all the good stakeholders because in a way, they're also committed to the network success. And if I am committed to the network success, and if I'm getting the right to add or to append the block to the chain, I feel a little more worthy of it, right? I feel that yeah, I'm contributing to it, and everybody else is acknowledging that part. So that is why, proof of stake is becoming the go-to consensus mechanism for the newer blockchain platforms. It's faster, it's scalable, it's more eco-friendly, to be honest. So yeah, while proof of work has already proved the concept, proof of stake is proving the future, balancing trust, speed with sustainability. Please know this. Balancing trust, speed, and sustainability, and this is how you should remember proof of stake, right? Let's come to the network now. The network always has been the invisible fabric that is tying the blockchains together, the peer-to-peer network or P2P. So unlike traditional systems where information has been always flowing through a central server, a P2P network is completely decentralized. All the nodes they talk to each other, becoming a client and a server at the same time. That means like I don't have to wait for a central authority to give me the permission that okay, I can now exchange data or the permission to get the data. I am a node in the network. I can directly exchange information with others, right? Because every node is going to hold the entire copy of the ledger. So even if one node is going down, none of the other nodes are disturbed. The process still goes long, right? Because data is already replicated across the network. The data is kept up to date in the network. And in a way, this makes system not only more resilient, but also more available. Transactions, verifications, they can happen anytime, anywhere. Think of it like you know, in the older days, we used to have an old library and every book is there, right? The entire city's books. Let's take the city in the scope. Every book is there. And if that library burns down, nobody has any book. But what is peer-to-peer network? Every house has the entire library with them. So even if one house burns down, the knowledge, the library, the books, they're still there, right? So yeah, it makes system stronger because as the participants join in, the system gets more stronger because everybody has the same copy, right? Next to the cryptography. Now, what is cryptography? We have seen all those components, but what about the security? So this is the component which is going to ensure our safety, our integrity, our verification of everything that is happening inside that ledger, the shared notebook, and across the network. And its security is not going to rely on a single lock because it's built on, because everybody is going to have the same ledger. So we don't have a single lock for us. We have some security components. Let's give a look to them. We have first hash function, then we have blockchain address, then we have digital signature. Let's start with the first one out here. The first one is hash function. Now, what is the hash function? It is like a digital fingerprint for data. Every piece of information, once it's passed through a hash function, it gets a unique output. Now, in the data, so now you see this was a data, and whenever it passes through a hash function, it gives it a unique output. So now, if you're going to change even a letter in this data, the hash function is going to change the output of the hash function is going to change tremendously, and that is how you get to know the tampering has happened. Then let's come to blockchain. Now, blockchain address is a very unique identifier that is based on the public key. How do you know this now? Now, let's suppose me. I live at a place, I have an address, right? I stay in this flat, in this block, in this society. Nobody else who is not staying in this house can have the same address, right? So that is it. It's a unique address for me and my flatmates. So every user on the blockchain has one blockchain address derived from his or her public key. And that blockchain address, it lets you send and receive transactions. It is your user ID on the network. It lets you send and receive transactions securely and in cases anonymously wherever it's needed. Then let's come to the digital signature. It's like CA signing off your audits. You know what? It's like your personal seal of approval. A digital signature is going to ensure that a transaction really comes from you and there is no mishap happening in between in the transit. It's a cryptographic proof of authenticity. It's a cryptographic proof of integrity, right? So together, all these components, they form the security shield of the blockchain, guaranteeing to you that hey, the data is secure, the data is transparent, transactions are verified, and trust is maintained, right? All this without needing a central authority. Let's come to the last component of the blockchain that goes by virtual machine. Just imagine your laptop, your phone, right? It has a CPU, it has a memory, it has storage, and all these things, it lets it run apps. Now, what is a VM or what is a virtual machine? It's like a computer inside your computer, okay? It is just like a software, but it behaves like a real machine where you can run your program safely. Got it? Now in the blockchain and especially on Ethereum, we have a special kind of VM called the Ethereum VM or EVM. Now, what do you have to think? You have to think about the EVM as a giant world computer that everyone can use at the same time, right? It's run by thousands of people all across the world. And what is its job? Its job is to run smart contracts, which are like apps, agreements that automatically do whatever they are programmed to do. The cool part is every single Ethereum computer runs the exact same EVM, right? So, what was virtual machine? A computer inside a computer. Now, all Ethereum computers are going to run what? Ethereum VMs. So, let's say if a contract says send cherish one token, every computer agrees and updates the record in the same way because they're all working over EVM. So all you can say is EVM is like a global shared computer that makes sure that blockchain apps, the transactions, they run exactly the same everywhere, anywhere without having a central authority, without anyone in charge, like a class having no monitor, yet maintaining discipline because of self-discipline. Do you get that? If anybody of you has any doubt, any concerns, please use comment section. I've also attached a Google form link in the description. You can just tell me about, you can just post any feedback. You can tell me, you can let me know of what changes I need to make or of the concepts you could not understand. I'll make additional videos for that. And if you want me to take any subject next post blockchain, you can also post about that. So yeah, if you could take anything 5%, 10% from the course video, go hit like, hit subscribe. Thank you so much. Bye bye.